video, we'll cover section 6.3 part 2. So the last thing we did on the previous video, we were converting from polar to rectangular coordinates. So now we're going to do the opposite, so, or the inverse, I should say. We're going to go from rectangular to polar coordinates. So like I told you earlier, you will need the last two formulas that we have here. So let's write them down there. So the first thing you should do is, if you are given a point, wait. There we go. So the first thing that you should do, and it is right here in your box, you should plot the point. Why? Because once you find the tangent inverse of that, okay, so this is the formula to find tangent of theta. So you all know that if we want to solve for theta, we're going to need to do tangent inverse of that ratio, which is y over x. Now, if you recall, there are two quadrants where the tangent is positive. What are those quadrants? One, no, not two, and three. Because here, the x and y are negative, so you divide a negative over a negative and you get positive. So for those two, the tangent will be the same. So there are two angles where the tangent will be the same. And of course, there are two angles where the tangent will be negative, which will be in quadrants 2 and 4. So that's why it is recommended that you plot the points first. Okay? So we're going to do that. And you can see it's already being done there. Plot the point in rectangular. And so that is here. So that way we know that we're going to be working in quadrant 2. So then the second thing we do is we find r by using the square root of x squared plus y squared, and that is here. So that's going to equal to the square root of -1 squared plus the square root of 3, and then we square it, like that. That will equal to the square root of 1 plus, what happens when you square square root? Cancels out, so 1 plus 3, so that's the square root of 4. And that is, think about it, well, in this case, it's just going to be 2. All right, and now we need the angle. That would be number 3. And so for the angle, we're going to use the formula tangent inverse of y over x. So it's derived from this one, of course. And that will be the tangent inverse of our y value is here, the square root of 3. And then our x value is here, -1. So we're calculating the tangent inverse of the negative square root of 3, correct? So go ahead and put that on your calculator. Tangent inverse of negative square root of 3. -60. So the tangent inverse function is defined this way. From -pi/2, which is down here, to +pi/2. Or in other words, like this. Theta is going to be greater than -pi/2, but smaller than pi/2. So when you put that in the calculator, it's going to give you an answer that, first of all, the tangent is negative here in quadrant 4. Right? And so, of course, it cannot give you a positive angle. It's going to give you a negative angle in this direction, and it's actually giving you something here. negative 60. However, we plot the point and we know that that's not what we need, correct? Yes, we need something in quadrant 4. So then what we're going to say is use one of those angles that has a 3 in the denominator. Pi over 3 will be here. 2 pi over 3. So theta is actually 2 pi over 3. Another way to find that is like if you don't use the calculator and you just want to use your intuition, you can think of it this way. For which angle, so we know tangent is sine over cosine, so for which angle is this thing, the square root of 3 over 2, and then a 1/2. We're talking about something in quadrant 2, so then the cosine is negative. And that's actually how you get your negative square root of 3. So which angle will that be? Where is the sine positive square root of 3 over 2, and that one will also be 2 pi over 3. Okay, so that is why it's so important. It's so important to plot the point. Of course, there are other ways to say that point. So the only way to say it is not only in polar. According to what we found, the radius is a 2 and the angle is a 2 pi over 3. However, we could also say, for example, like what Taylor told us about the calculator, it was like a negative 2 pi over 3, right? So we could use that angle, and then how can we make it just reflect? What we do with the r, multiply it by negative 1, right? So another way to represent this point could have been negative 2 pi over 3, like right here, actually negative pi over 3, I should say. And then we make the r negative. And isn't it that one of the ways that we did earlier? Yes, it is. You take your angle, and then, well, I subtracted instead of adding. Yeah? No. Yes, subtracted. And then I made my r be negative r. Okay. I mean, there are multiple other ways to represent that point. So let's do one more. And now for this one, first of all, we plot the point, which is negative 2, 0. If you didn't have the drawing, right, you should know. Negative 2, 0, so it's here. And so it's very easy to see what the angle will be, right? If we start from here, just like we have it here. Pi. But still, you need to, show some stuff. So, for example, we need to find r. So for that, we say r equals the square root of x squared plus y squared. So r will be the square root of negative 2 squared, right here, plus 0 squared for y. That will give us the square root of 4 plus 0, which is just the square root of 4, which is just 2 or negative 2. What do you guys think?
Wouldn't it be plus minus? Yeah.
Well, yeah. So it's actually, we have a lot of options. We can say 2 or negative 2, but we just gotta make sure that the angle is correct. All right? So I'm going to leave it at a positive 2 there, because we're going to use pi. So we go over here, and 3 is to find theta. So for that, we will say tangent inverse of y over x. So that will be the tangent inverse of, okay, y is 0, and x is negative 2. So that will be the tangent inverse of 0. Another thing to remember is the tangent is sine over cosine. And so anytime the sine is 0,
It's undefined.
the cosine, no. I'm sorry, if the sine is 0, the tangent will be 0. If the cosine is 0, the tangent is undefined. So in this case, remember that tangent inverse is defined this way. So if you were to put that question on the calculator, this question here, what do you think the calculator will tell you? 0. It would give you this point right here. However, we know that the point that we plotted is right across, right? So in this case, we need to say that this will be pi. So one representation in polar form will be the one that we found numerically. The angle is pi and the radius is positive 2. Like if this was one circle and then this is the second circle, right? We go pi radians and then 1, 2. There. What's another way to represent that point? Negative pi. So that would take us here, right? And then 2. Very good. Or, what else can we say? What if I told you that you could just keep adding like a full circle? So what will be the next one?
So infinite pi?
Pi plus 2 pi? 3 pi. Yeah. Or what if I ask you, I want r to be negative. I want r to be negative 2. So then what would you tell me? Oh, we had one, right? 0. That's 0 and then negative 2, so opposite side. Or what else? Let's find another one. Let's find one with a negative angle. Let's see. Negative 3 pi. Will that work? If I put a negative 3 pi, what should I make my r? Positive or negative?
Wait.
So negative 3 pi, I'm going in this direction, one full circle, and then half of a circle. So do I need r
So
to be
just
positive or
yeah,
negative?
positive.
Positive. Not really. If you just, it has to match the plot. Like there's no really plot. Okay, let's do this one quickly. Well, you guys do it. I don't need to. Do it with your partners. Okay, so let's check out the answer. So here we should have something like 0 squared plus negative 4 squared, which is just going to give us 0 plus 16, and that will be equal to 4, right? Oh, and at this point, we can assume 4 is positive. That's fine. But remember, we're saying that r is 4, but that doesn't limit our options to represent a point, right? Depending on the angle. So then, for the angle, I know that you're going to get something that will be undefined for the tangent. So it's going to be, what was y? Negative 4? Over 0. So we already know this is undefined. So then ask yourself, where is the tangent undefined? And that's,
I got plus 90, I mean plus minus 90.
okay, so anytime the cosine is equal to 0, the tangent will be undefined. Where is the cosine equal to 0, or the x equal to 0? Here
90.
and here. So we could use different angles. For example, you could use pi over 2, or you could
pi
use
over 2.
negative pi over 2. And so that's what I was talking about. If we graph the tangent as a function, not on the unit circle, it will have all those asymptotes at multiples, odd multiples of pi over 2. So it's that, and then the next one will be at 3 pi over 2, which will be the same as pi over 2 plus pi. And then the graph goes like that. So the tangent is undefined at all of those odd multiples of pi over 2. So we have like several options here for theta. We could say we want theta to be negative pi over 2. That would make sense, right? If we were here, we go to negative pi over 2, And then our r, we keep it positive. But what if I ask you, I want a positive angle. I don't want my angle to be negative. What would I have to say? Very good. So we will have to say 3 pi over 2. And then the r will still be 4. Well, what if I say I want my angle to be, let's say, I want it to be positive pi over 2. Then that will be here, right? And so we want it to be, our point to be here in the opposite side, so negative 4. Very good. That's why your robotics teams.
Mr. You said something that if we get first base, I'm not going to unit cycle.
You're not gonna what?
I'm not going to unit cycle.
Unit cycle?
Unit cycle.
A unit circle?
Oh my god.
Like a bicycle with one wheel.
Oh, that's also.
Bro, it's all about tricycles.
I'm too for that.
Yeah, what about for tricycles?
Okay. Let's now. Are we clear how we're gonna change points? Yes. Formula. Now let's see how we're gonna change equations in rectangular to polar equation. So a polar equation is going to be an equation whose variables are r and theta instead of x and y. Okay? And we're going to use theta as our independent. And so what we're going to do here to convert from from rectangular to polar, we're going to replace x and y with the two formulas that we already used, r cosine theta, and for y, we will use r sine theta. So we start here with the first one, a, and instead of x, I will use r cosine theta plus, and then instead of y, I'm going to use r sine theta, and then that will equal 5. Now, what do they both have in common? My two terms on the left. They both have r. So we can factor out the r, and that will turn this into cosine theta plus sine theta. So then it says here to express an r in terms of theta. So we're solving for r. So let's add this here and solve for r. So to solve for r, the stuff in the parentheses is multiplying to the r. So we're going to take it across and it's just going to divide. Cosine theta plus sine theta. And that's it. Okay. Now, let's do the next one. Well, let's go ahead and graph them so you can see how they're graphed. So go to your calculator. And then we're going to go to the graphing section. And then we're not going to enter it in terms of x. We need to graph a polar equation. So we're going to go to menu. And then number 3 for graph entry. And then there's one that says polar, number 5. Okay, and so what do we say it was? 5 over, right? So I'm going to get my fraction tool here. It's a little slow. Okay, so 5. And then we have something like where's theta here? Plus sine theta. Do you guys graph it already? What do you guys think you will get? You got a line. Weird, right? You have sine and cosine, no wave, nothing. But if you look at what the equation was before we turned it into a polar,
It is a linear.
it's just a line. It's just negative x plus y. Isn't it true? Yep. So whether you graph them in rectangular with the correct equation or in polar with the correct equation, you're going to get the same image. All right, now let's do the next one because that one requires more steps. So we're going to use some algebra skills here. So same steps, we're going to replace this x and this y with the two statements. So instead of x, I'm going to have r cosine theta minus 1 from here, and then square, plus, instead of y, I'm going to have r sine theta, and then square. And that is equal to 1. Now, when we square, this is a binomial because we have two terms. So we have to square the first one. So it will be r squared,
Theta squared.
cosine squared, because we have to, not the theta, but the cosine, we have to distribute that to this two, to the r and also to cosine. And then the
Negative-
term in the middle is the
Negative
product.
2r cosine theta.
Good. Why is it negative 2?
Because we double it.
Because we double it, right? And then the third
Cosine
term
squared theta.
plus, we square the negative 1.
I mean, yeah.
We get a 1. Okay, now the next one is going to be r squared and then sine squared. Again, we must distribute that square to here and here. And then here we just have 1. Okay, so let's see what we can do.
Is it possible to use like any Pythagorean identity on it?
Yes, we're going to do that. But first, let's get rid of the one on the right and the one on the left. Like if you just subtract 1 to both sides.
And then would you factor the r?
Yeah, so now we're going to get these two together because Andrew wants to use the Pythagorean identity. So what do they have in common?
R squared.
R squared. So if we factor r squared from here, we get cosine squared theta. And then if we
Sine
factor from here, sine squared theta. And so that's great, right? Because we can just substitute that with a number. What number? 1. Very good. Then we have negative 2 r cosine theta. And now what do I have on the right side?
1 or 0.
0, which is good. So, let me
We
think.
just
Oh
have
yeah,
r
let's
squared.
replace this with a 1
Minus 2r cosine.
by the Pythagorean identity. And so now we just have r squared minus 2r cosine theta equals 0. And then we're gonna, now they both have something in common, right?
So,
R,
so would it be a parabola? Kind of?
I don't know. We'll discover that. Minus
It's a
2
quadratic formula.
Cosine
What
theta.
is
Well, if you remember from chapter 1 last semester, that is the equation of something else besides a parabola. It's a circle.
Oh, right.
With the center where, Matthew?
At the order.
Not at the origin.
No.
Zero somewhere else. Negative 1.
1, 0.
1, 0. Yeah. Thank
You almost
Okay.
got it. Okay, so from here, you're actually going to come up with two equations. So one of them is going to be r equals 0, and the other one will be from the next factor, r minus 2 cosine theta equals 0. And then if we solve for r, we will get positive 2 cosine theta. So let's see if we get that. Let's go graph it on our calculator. First. Here, so I'm just gonna delete that one. that I have. And so remember, we're gonna enter it as polar, and that was 2 times cosine theta. And there we have it. So if we were to look at the equation in rectangular form, it was like x minus 1 squared plus y squared equals to what? 1? So this was our circle with the center at 1, 0, which is here, and then with a radius of 1. All right. So we have one more slide, right? Okay, now we're going to do the opposite, so stop talking so we can finish. We're going to convert from polar to rectangular, not just points, but equations. And of course, we're going to revisit and reuse all these formulas, right? So keep those in mind. So what can we do with the first one? A. It's just r equals 5. Think about it, like, what would it look like if you don't care what the angle is, but you just care about all the points that have a radius of 5? It's a circle. Yeah, it's going to look like a circle. But how can we, so this is a circle, we know that, because you guys are very smart. But how do we want it to look? It's going to be a circle with the center at the origin, and the radius is 5 squared. Okay, so let's see how we can get to that. So we're going to use okay, so we're going to use the r squared equals x squared plus y squared. Pretend that we don't have this yet, okay? And then we use the number that they're giving us, that's all we have, to substitute it here in place of the r. So then we put here 5 squared, and that will give us 25. And that's it. We don't do anything to the x and y, which is even like that. So you only have the r to substitute, that's all you use. Now the next one is going to be we don't have r, we just have an angle. So think about it. What would it look if you just plot points for that angle? It's a line, yes. And it doesn't matter if r is positive, if r is negative. It will all be like that or that. Okay? So then we're going to get a line. And it's a very famous line. Yes, the identity function. So let's see how we will find it. Let me see. Okay. So this is very simple. So we say that tangent of theta is y over x, right? So then theta is going to be the tangent inverse of that.
Of y over x.
Of y over x. But in fact, we're just going to use this one because we're going to say the tangent, and then we substitute all we have, and that is pi over 4. And what is the tangent of pi over 4? Positive 1. So what does that mean? It means that we have 1 over 1. Therefore, y equals 1 and x equals 1. So then the equation, when we put it together, it's just going to be y equals x. Okay, the next one, part C. We have 3 cosecant of theta. Oh, and then we have r. Okay, so let me see. Okay, so let's go ahead and use first a reciprocal identity. Now, if you guys recall, our formula, we don't have secant or cosecant, we only have sine and cosine, right? So let's convert that cosecant to sine. So it's going to be r is equal to 3 over sine theta, right? Isn't it true? Yes. So then, if we take sine theta is dividing the grid, so if I take that across, what is it going to do to the r?
Multiply.
Multiply. And so what do we say about r sine theta? That equals to x or y? Right here, it equals to y. So we just replace that with a y. And so what kind of line will that give us? Vertical or horizontal? Well, all lines are straight, right? Well, not all, sorry. And Euclidean geometry. What would that give you? Horizontal or vertical? Horizontal.
Because so sine is y.
Okay, so now let's look at the last one, D. And for that we have -6 cosine theta. R equals -6 cosine theta. What should we do, guys? Ooh, I remember. Say that? Replace cosine? No, we want to keep cosine. If it was secant, yes. I would say this is cosine. So this is going to be like a weird trick. And I have to look at the book so I can remember. We multiplied everything by, so let's just write it. Multiply by r. So then both sides. So we're going to have r squared here. And then on the right side, I'm going to have -6r cosine theta. Now, why am I doing that? Well, because I want to replace this with either x or y, which one? With x. So -6x. And then there's another relationship for r squared. And that one is here. Where is it? Here. So instead of r squared, we're going to have x squared plus y squared. Then, when we have x and y squared, that means we're going to have a circle. So this is x squared. I'm going to take this one across. So it's going to be positive 6x. And then I have here y squared. And then here I'm going to have 0. So I'm going to do this thing called completing the square. So I'm going to take the x values, like this, x squared plus 6x, and then I'm going to make up a number that will come from here. Half of 6, what's half of 6? 3, and then we square it, so that will be 9. Like that. And then here is going to be just y squared. And then here we're going to have 0. However, since I added 9, I just made up that number to keep the equation balanced. I have to add a 9 over here as well.
Oh, yes.
Do you guys remember a little bit from last semester? And so we have that, and you guys need to review this because we're going to need it for chapter 9. So then we forced this one to be a perfect trinomial square. We did that because we wanted to be able to factor it like a binomial being squared. And so that will come from the square root of this one here, which is 3. So then this one becomes a circle with the center. So the opposite of 3, which is -3, and for the y it's just 0. And radius of 9 or 3. This one is actually giving me the r squared. So r squared is 9. So r is 3. Okay. All right, great. So we're stopped.